So today I'm going to show you how to model a truss. First thing, let's go to the internet and download Ftool. So to download Ftool, you go and Google Ftool. And the first website that you see is the site for Ftool. Sometimes the internet says that this is not a website that you should trust, and then you can add an exception, okay? But anyway, let's say that if you have a Windows, you can download the first version here of Ftool. If you have a Linux, and you can download another version. There is a manual in English for Ftool. If you have a Mac, as I do, you can actually go to the internet and download a software called Wine Bottler. Okay, and with this software you can run any .exe file, meaning that you can run Ftool. Okay, after you download it, you have a icon that you can use. So Ftool, let's click here. If you have Wine Bottler, we will ask you what would you like to do. You just say go. Okay, so here's Ftool. First thing that I'd like to do is to thank Luis Fernando Marta for providing this software that is super useful and very friendly. Okay, let's close here and let's start with the tutorial. First thing, this white screen is the graphic interface that you have with the software. Here on top you have file save, file print or export screen, which is very useful when you are doing your technical memo. So you can export as a PDF, and then you can paste this PDF in your Word file or any software that you're using to write your report. Another very useful thing is there is a units and number formatting. Let's click here. So now it's set up to use SI units. Let's use US units. There are a couple of things here that we have to change for our exercise today. The first is the length. Let's get a length in inches. Okay. The second one is the force. Let's get forces in pound. And then the third one is the elastic parameter, which is the Young's modulus. Let's get a Young's modulus in pound per squared inch. The last one here. Okay, so now we are good to go. Let's press OK. So another thing about Ftool, here on the bottom you have X and Y, so you know where in space you are. Let's see, like now I'm 9.6 inches in X and 100 inches in Y. You can select a grid. So let's put a grid, and let's put actually a grid every 2 inches. You just change here to, and let's use the snap. Okay. The first thing that you have to do to create our truss is to create nodes. So let's insert a node. Okay, so you could insert a node just by clicking on the screen. Let's actually insert a node with the keyboard. So you click on the keyboard and then you click insert a node. And let's start my truss in a X and Y equal to 0. I'll press OK. The second thing of my truss will be X equal to 6, Y equal to 0. I'll press OK. And the next one, 12. So let me close this. And when I go to world view, so world on screen, they call it, and you have also zoom in, zoom out, and everything else. You have here the grid, and then the red, they are the nodes. If I click, so let's unselect keyboard mode, okay? If I click on member, insert a member, I'm going to create from this node to this node one member, from this node to this node another member, and with this I have the bottom chord of my truss. And if you check, so if you check here on the bottom we have X and Y, right? So 0, 0, and then the next node on 6, 0, and the next node on 12, 0. Perfect. Let's create another member. As I mentioned before, you don't really necessarily have to create a node and then create a member. You can create members and the nodes will be automatically created for you. Let's create a member from the end here to 2 ints up in the middle. So x equal to 6 and y equal to 2 inches. Create here. Let's connect to the end of the truss. And let's make a truss like this. Perfect. So this is the most simple truss that you can create, I believe. Let's go back here to select mode. The idea of most of the structural analysis softwares is that you're going to start on the left and then you finish on the right of your software, okay? So let's start here on the left. First thing is material parameters. When I have this selected, I'll have a screen here on the side that will ask me what are the material parameters. Let's create a new one. To create a new one, you just click on this blank paper here, and let's create a pasta, right? So our bridge is made out of pasta. Let's create a pasta one. Done. The Young's modulus for the pasta, as I measured before, is 1 second that I have here in my notes, is 35,000 psi. 35,000 psi. I can apply this material to all the members, so I can create here all, okay? And then every single member that I have here drawn now will have these characteristics. So this Young's modulus, this specific weight, and this alpha. Specific weight and the alpha, now we are not going to play with this, so you can leave any number basically. Let's change now the cross section. So from left to right, the next one is the cross section. Let's create a new cross section, and I'm going to say this is a rectangle. So let me put just rec. And I'm going to click here, section type, a rectangle, done. So I'm going to make here a rectangle of 0.25, 1/4 of an inch, 1/4 of an inch. It's actually a square, right? And I have here, it automatically calculates the gravity center and the area and the inertia, and I press all. So every single member has the same dimensions, the cross-section dimensions now, okay? The third thing, from left to right, are the supports. So the supports for everybody will be the same. I'm going to restrain in one end X and Y, and I click there. I select the other node, and I'm just going to restrain in Y. So I have a truss like this one. Okay, so next thing, from left to right, I have here rotation release. So as the instructions has mentioned before, the trusses, one of the characteristics is that the members only work in tension or compression. So we have to release the moments at the nodes where all the members they get together. So let's select the nodes, and one way to select the nodes is you select the node, one node, and then you hold the shift key and you select all the other nodes. And this is the symbol for rotation release. Let's apply. And here you have all the hinges applied. So you have this empty circle. This is the symbol for hinges. And please don't forget it. This is the concept of a truss, and you have to have it. So the next displacement constraint, you're not going to work with this. And let's start applying forces now. So the machine will actually apply a force on the bottom chord of your truss. And this force will be of 120 pounds maximum. The machine can't apply more than that. So let's create this force. I'll create a new force, 120, and then I'm going to apply. This force is a force in Y of minus 120. Why minus? It's because it's going down. So I have the force there. And this is my truss. My truss is ready to, we are ready to actually get all the forces. All the rest here of the loads we are not going to work today, so this would be like moments applied, uniform load, temperature loads, or load train, like cars running, all that kind of stuff. So let's go here to the right side, and we are interested to know what are the actual forces in each element. I'll click here and ask me to save before I proceed, so let's just save. Okay, you can change the dimensions of the graph by moving this little thing here. Okay, so here we have it. I have 120 tension in this member, 180 tension in this member, same as here, and then on the top chords I have compression of 1.90. So you know it's compression because there is a minus sign in front of the 190. Don't forget that when you have compression, you have buckling of this member, and you should be very careful bracing this structure, and you make sure that this member will not buckle on the plane of the truss. Okay, so be very careful of this. Another thing that you have to check is the displacement. So the displacement is the very last icon that we have here, the formed configuration, right? So click here, and when I click on the node that I'm applying the force, I'll get the displacement. So my truss is displacing negative, meaning going down, 2.77 inches. Well, this is more than we actually had intended to model to make a truss for it. We were thinking about, well, actually we mentioned that you can only displacement 2 inches, and because of that you should optimize your structure and make sure that you have like a truss that will not displace that much. One thing is that we are modeling now just one plane of the truss. When you're going to test, you're going to have 2 planes, meaning that this is the sum of both planes. In here, 2.7, if you have another plane with the same truss and same material, same cross-section, this will be divided by half, and you'd be under the 2 inches limit. Okay, this is all that we need to know today to model the truss. Thank you very much.